So the next topic we are going to start here, that is called joining and relationship. It will not take much time toward data modeling. It is going much faster. So I'm going to start here. Now let's go for joining and relationship. Joining and relationship. So there are four types of relationship. One is called one to one. Second one is called one to many. The third one is called many to one. The fourth one is called many to many. So ultimately, we have given these are the different relations we'll do it. What I'll do here, so let me keep on adding this here. I'll be starting with one to one first. Then I'll be moving with one to many is the second example here. Then I'll going for many to one is the third example here. Then we will be doing many to many as the fourth example for the relationship here, right? Going to one, what I will show you here in this data set for the session 3, if I go to the raw data, I have given as relationship data. Now taking this relationship data, I want to show you what I'm planning to show you as a relationship. For example, for example, I have given this player's score details. I have given this player's expertise details. Now in this both table, right? When I want to see the relationship, I would be going for making relationship between what? It is your player's ID.
Yes,
Yes
sir.
or no, guys? Right. In this player's ID, if you look closely, the relationship that it is going to build, it is players one to players one, right? It is going to be players two to players two, players three to players three, and is going to create players four to players four. Same way, it will also go for players five to players five, players six to players six, and player 7 to player 7, each row are going to connect from both the tables. Ultimately, the output that is going to come here, it is going to come as player's ID, player scores, player's name, and expertise. That is what the final output which is going to come. So I just copy this and paste it over here. So ultimately, what we are discussing, this relationship between these two tables are going to have a relationship called one to one, and the output will come like this. And this is an example of making a relationship of what? One to one. Does it make sense to all of you guys, everyone?
Yes, sir. Yes, sir.
Right? So that is how we understand how the relationship has been built up from all these tables here. And this is an example of what? One to one relationship. Clear now to all?
Yes, sir.
Right. So let me go ahead and take this. So I will be taking this to your program here. When it's coming to one, I'll be pasting this here, selecting this, delete. Right. So this is called one-to-one relationship. Now, how to program this one-to-one relationship? First of all, I have to go for importing the data. So the importing data, I'll say import pandas as PD. I call this import numpy as NP. I go for file underscore path, which is R, given this file path, which I'll be taking it here. Then I would be going for player score, rename this to, I'll go for the file name, which is given as relationship data dot excel sx file. Now to check this field name called players score, I will write pd dot read underscore excel bracket start, go for a file path, call this sheet underscore name. The sheet underscore name is going to be player score. Same way, I can go for the next table, which is called players expertise. For that, I'll be taking this players details out here. To print, I will say print this players score. I will say print the value for players expertise. Now, if you run this program, you see players scores and players expertise both are coming. To get this final output, what we have to do here, we have to write import pandas as pd, import numpy as np, where I want to get player scores and the expertise. I will use pd dot merge. The left table is players score and the right table is players expertise, and how is going to be inner join or let it be left join, doesn't matter. Then on the field name which is called as players id. Now if we run this program, ultimately what we are expecting, the number of records should be coming to what? 8. Does it come? It is coming with 8 records. Player side with score and the player's name and the expertise are coming. Does it make sense to all of you guys, everyone? Yes or no?
Yes, sir.
Right. Now, what I will do here, one to many relationship, I have given the player's expertise. I want to go for importing the further table that is going to be here, my score. This is called as match score. So I can say rename and take these values here and I call this match underscore score. Now, when I say one to many relationship, what does it mean? Here is an example. Now, we have in this example, we have given the players details here. In this, we have also given players score here. Now, if I look forward to have the relationship between these two tables, how it is happening? It is happening from this to this here. This is an example for what? One to many relationship example. Does it make sense to all of you guys, everyone? Right? Now, if you look for P2, P2 will also go for twice because P2 has played the match 1 and match 2 as well. That's how the relation is going to one to many. So ultimately, what result is going to come in? The result is going to come, the final output is going to come like this. From the left table, you will have the right table output where the same player will replicate here for this. So this would be your many to one relationship.
So
Does it
one
make
to
sense?
many.
So this is called one to many. So ultimately, we are getting the final output, which is going to come this way. Is this clear now, guys? The common field in both the tables are going to be what? Player's ID, but this is how the final output is going to come. Clear now, everyone? So I can just copy this output, taking to here, make this to markdown, paste before this last run. So this is what we want to do, one to many relationship. Now we have this should be taken to what, guys? One step up. copy, paste it here. So this should be one step up, right? This is called one to many relationship. For this, we have imported the file. Now let's write the program here. What program we'll write here? We'll just take it here to final output. In this final output, your left table would be this, your right table would be match score. Left on the common field name is players ID. Now if you run this program to players score expertise, or you can call this players expertise underscore match score. If you want to call this, you can see the output which is coming this way. First, you import the data. Second, you run the program. You can get this. Totally 16 records are coming. Does it make sense to all of you guys, everyone?
Yes, sir.
Right. Now we'll start with what? Many to one relationship. What is many to one relationship? Here, let's say your this table is given as a left table. This table is given as your right table. How do you make a relationship between this table? You will say this to this table can be connected by what? Right. So this is an example of you can make the player one for match one to get the player expertise, player one for match two, the player's expertise. Same thing you can also apply for player two here. Now the player two expertise can also be mapped from here to here. So this is an example of many to one relationship. Ultimately, what result is going to come out of it here is that when you say many to one relationship, it is going to be the entire part of left, which is going to come here, connecting to the player's score, which is given here for same score would be replicate here. We have to copy this, paste it here. Now the same score is going to replicate here and here. So let me put this way here to get the value. Right. So ultimately our final output, which is going to come this way. Does it make sense to all of you guys, everyone? Are you getting this? Now copy this here, take it to markdown code, call this code here, right? I just select this here to delete and run. Now to get this output, how do you go for getting this output here? The same program to get the final output. We have match score. This table is going to be the left table. This table is going to right table. Based on this, if you run this query, you can see the output is coming for starting with player's ID, score, and the match. You can see the player details here. Just the opposite. That is where we can call this as many to one relationship. Now, how to go for many to many relationship? Now we'll do this example here. For many to many relationship, we have given data here, which is called series score. Now we also have given players score contribution here, right? So ultimately, if you look at here, in both the table, what is the common field, guys? Company and country and country. Yes or no, guys? Everyone, guys, are you there?
Yes, sir.
Now this country is duplicate because of what series? This country is duplicate because of what score? Now, when country is duplicate because of series, country is duplicate because of the score, this type of relation is going to be many to many relationship, right? So ultimately, what you're trying to show here, your country score, which came for India, it is going to be in the first, the score for India in Northwest Trophy. The score is going to divide among the 4 players. Are you getting this? Everyone, correct?
Yes.
Now, same way, this will also repeat to all these 4. This is going to be many-to-many relationship for what? For your now India is going to have India NatWest is going to have 4 records. India, the next HSBC GLAD is also going to have 4 records. This is how the relation is going to create for each row for India is going to have 12 records for India. Australia is going to 3 into 3, which is going to be 9 records. So ultimately the output which will come here. So how the output will look like, guys, after merging this table, the output will go like this. For India, it will show right, correct. Now for this, it is going to score 4. For this, it is going to score for 4. This is 12 records. Now for Australia, it will have 3 records for 3 players. This will repeat for Australia, the Glad, Australia, and this also, right? So this is going to be your output for many to many relationship output. Are you getting this, guys, everyone? Now, how to get this output to the program and to present it here? So let me copy this, take it here, call this markdown, paste this, select from the last exclamatory mark, go to the top, remove everything, run this code. This is an example of many to many relationship. How to go for doing that? We will be going for importing the data. So let me go and import the data for you guys here. We will be importing data from this table called series score. I'll be putting it here. I'll go for players score contribution. So I call this as series underscore score. I call this as players contribution. Now let's run this program. This is how the output comes. To get your many to many relationship output. So how will you go for getting this? Import pandas as PD, import numpy as NP. Go for getting this new table series score to contribution. So you like PD dot merge bracket start. Your left table is going to be the series score. Your right table is going to be your players contribution. How? I want to put it here for left join. Now on, I want to put it here the field name called country. So I close the bracket. I call this table to be printed here. So let me print this output. What I see total is 21 records are coming. Are you getting this, guys, everyone? It is going to be how many records? It is going to be 21 records, which is also coming in what? Many to many relationship. So we can get many to many relationship of 21 records. Is this clear, everyone? Is this clear?
Yes, sir.
Right. Now I'll have a test for you guys, and you have to tell me how many output will come from there. So the test which I want to give it to you this way. So let me give you the test. Okay. So I just call this as a test. Right. I call the table name is going to be student ID S1, S2, S3, S4. It is also given S1, S2, S3. Now it is given S4. It is also given S4. It is also given S4. It is given S5. It is given S5 twice. And also it is given S6. Now I call this table underscore 1. So I call this table name as T underscore 1 table. Now I create this data frame. Okay. Now I call this another table here, which is called table 2. Am I doing anything wrong here in this?
There is no first finish 6.
Yes. Okay. Now I go for table 2. In table 2, I took S1, S2. I took S1, S1, S1. Right? I took S2. I took S3, S3. I took S4, S5, S6, and S7. Is this clear to all of you guys? Everyone? Clear now? Right? Now you have a table 1. You also have a table 2. I want to ask you guys, when I merge these two tables, how many records will come? Tell me how many records will come in inner join. How many records you will get inner join? How many records you will get it for full join? How many records you will get it for unmasked join? How many records you will get for left join? How many records you will get for left null join? How many records you get for right join? How many records you get it for right null join? Okay. So tell me guys, how many records? Okay. Now how many records you will get for add one more thing. Now you add one more thing as left null join, right join, and right null join. Okay, looking at this table, guys, can you tell me how many records will come under inner join? Guys, how many records will come under inner join? Are you able to find it out?
14.
Sorry,
14.
inner join. You're saying how many records will come?
14.
13. 13.
First of all, you understand. Tell me for S1, what type of relationship?
Many to many.
Many to many.
Many to many. And how many records will come?
6.
6 records will come. Okay. Now let's look for S2. What type of relationship it is?
1 to
1 to 1.
Huh?
1 to
1 to
1.
1.
1 to
1.
1. How many records will come? 1.
1.
S3, what type of relation is going to build up?
1 to 2.
One to
Many
many.
to
Sorry?
One to many.
1 to
One to many.
many. How many records will come on S3?
Three.
Three.
Two.
2, sir.
Two.
S4, what type of
Three.
relation is going to build up?
Many to
Many
one.
Many to 1.
1.
Many to 1.
Okay. How many records will come for S4?
3.
3.
Two.
3, sir.
3.
Three, sir.
S5.
S5, what relation is
Many
going
to
to
one.
build up?
Many to
Many
1.
to 1. 2.
Many to 1. How many
Two.
records will create?
Two.
S6,
One to
1
one.
to 1.
S6,
1 to 1.
how many records will create now?
1.
1.
One.
Right.
Total 15.
S7,
1.
One.
it is
Left.
left null
Left hand.
Left.
and 1 record.
One.
Correct?
Yes,
Is
sir.
that clear? Right.
Yes.
Yes, sir.
So ultimately, in inner join, how many record will come?
15.
15.
6, 7, 2, 9, 3, 12, 2, 14, and 15. Okay.
15.
Full join,
So
how many
how
records
is
will come?
S4 3 that many to 1? How it will become 3?
16, sir. 16.
2, and this is going to be 3. 2, 3,
No.
6.
S4
Correct.
1. S4.
S4 is
S4
going to
with-
3 and only 1 here, na? So
Oh,
many
okay,
to
okay.
1.
I missed it. Yeah. Got
Okay.
it.
Now, how many
Mhm.
records will come under full join, guys?
16.
16.
16. When I say unmasked,
1.
how many records will come?
One.
1.
One.
When I say left join, how many records will come? Left join,
16.
15. Yes.
15.
Left null join,
One.
left null join,
1.
0.
0.
0, sir.
0.
Right join. How many records will come?
15.
16.
16 is
Right null join. How many records will come?
1.
1, 1.
Yes or no? Are you getting this?
Yes, sir.
So we'll start with data modeling. So in data modeling, in the joining, relationship, and data modeling, we have two types of data modeling. Is two types of data modeling. One is called Star Schema data model. Second one is called Snowflake's data model. So in Star Schema data model, we call this as all dimension tables are directly connected to the fact table. Now, when it comes to Snowflake data model, not all the dimension tables are connected directly to the fact table. Now, what does it mean? Let's understand in a very practical way here. So we have given a table. The table name is called data modeling. Data modeling by examples, which is given here. In this, we have a transaction table. Transaction table is given as order ID, order date, customer ID, product ID, and quantity, store ID, and staff ID. You are given the customer table with customer ID, customer name, date of birth, and mobile details. Product table, product ID with product name, category, price, and inventory supplier is given. Store table, store ID with store name and location of the store is given. Staff table with staff ID, staff name, designation, year of experience is given. Supplier table is given, supplier ID with supplier name and location is given. What is Star Schema data model? You have a transaction table where you have these fields. You have a customer table where you have these fields. When you want to make a relationship between sales to transaction to customer, you go by customer ID. In the customer table, you have unique customer information by customer ID, which is called primary key. In the transaction table, customer ID, which is called duplicate in nature, the same customer might have done multiple transactions. We call this reference key. So a table where you have duplicate or reference key, we call fact table. A table where you have unique key or primary key. Primary key means unique information about customers. This is called dimension. Same thing. You have a product table as a dimension table connected to the transaction by product ID, which is a reference key, and product ID in the product table is called primary key. You have transaction to the staff master, it is by staff ID. Staff ID in the dimension table, staff master is called primary key, and here it is called reference key. Now, store to the store master, transaction store master by store ID. Store ID is called as a reference key, and this is called primary key. When your fact table directly connected to dimension table 1, 2, 3, 4, we call this as your Star Schema data model. Now, how this Star Schema data model works? Now, let me show you in this example here. I can copy this. I can go back to data modeling. I can say Star Schema data model. In this, I paste these values. So this is the Star Schema data model. For this to do, I write import pandas as PD, import numpy as np. I will give file underscore path where I want to take the file from this path. So I'll say R Unicode value to the file name, rename this file called .xlsx. Then in this file, I want to read the information like transaction master. So I will be writing here transaction underscore master, which is pd.read underscore excel. Given the file path, seat underscore name is going to be this. Rename this called transaction table. Now you got to do this. One is transaction master, one is customer master, one is product master, one is store master, one is staff master. You would be going for rename this to customer table. You'll be going for rename this to product table. You'll be going for rename this to store table, you'll be going for rename this to staff master table. So ultimately, we have tables like transaction master, we have tables like customer master, we have product master, we have store master, we have staff master. If I run this query, I see some error. Somewhere I have done read.excel,
That's
right? So I just have to write this and run this query. I still get some error called path.
the file path, only path.
Okay. So maybe, okay. Now if you run this query, what is it happening guys here? It is coming with what? All these tables which is coming. Now in this, we have a fact table, which is called transaction master, where all the reference key are located. We have a dimension table 1, which is customer master, where we have the primary key with, what is the column name? Customer ID is located. We have dimension 2, 3, and 4. This is my product master. This is my store master. This is my staff master. This is by prod ID. This is by store ID. This is by staff ID. Now, since we understand this table, to design the data model, how do you go for doing this? Transaction master to customer master by customer ID. You'll go for transaction master to product master by prod ID. Transaction master to store master by store ID. Transaction master to the staff master by staff ID. Right? So how to go for doing this? Let's write import pandas as PD, import numpy as np. Let's create data underscore 1 pd dot merge. Your left table would be transaction master. Your right table would be your customer master. Your how would be left join. Your on would be, what do you call these guys here? It is by customer ID, right? This is all about data 1. You create data 2, where you take,
Sorry, you did mistake on spelling of half. HOE.
this is how. Okay. Now, how would you go for doing this here, guys? This is data 1 connected to your product master table by the field name is called product ID. How would you go for connecting this with 3? It is going by what? Data model 2. It is going to be your store master by your store ID. Then you would be creating this, call this as final output. You will take data 3 as left table, staff master as a right table, left join, the common field name is this. Now, if you write here final output, you can see the output is coming for 32 records. It is having all these informations properly, which is given. Does it make sense to all of you guys, everyone? Right? You have customer ID. Now, how to get this data properly written? You can say dot columns, dot values. The moment you run this program, you see the header is coming. Now, how to make this header? So you can say this is underscore version 1. You can call this as keep underscore where, start this, get all these variable list, do a data normalization. Order ID, customer ID. What information you want to keep here, guys? Customer name, date of birth, and this all. Besides to what? Customer ID. Yes or no, guys? Product ID. What do you want to keep? Product name, quantity, supplier. So this all information you should keep it beside to the product ID. How to go for keeping this as your store information? So you can say the store ID with store name and location details over here, right? Then for staff ID, you can have staff name and this information, right? So ultimately, what happens when you say final output version 1, final output, you can write here keep variables. Now, if you go for printing this output, what is happening here? It is going to give you a complete structured way. Order date, customer ID, customer name, date of birth, and mobile, product ID, product name, category, price, and all details are coming. Does it make sense to all of you guys, everyone? Is this clear? Guys, are you getting this?
Yes, sir.
Yes.
Right. Now we'll talk about Snowflake data model. What is Snowflake data model? Now let me show you here. Okay. Now for the Snowflake data model, guys, what you see here in this file, right? In this data model, not like every dimension fields are directly connected to the fact table. It is a supplier master table, which is connected to what? To the product master by supplier ID. Then it is connected to your fact table. So in such cases, you can copy this, go back over here, mark down, present this here, select. Now run this query. This is for Snowflake data model. In this Snowflake data model, what we are going to do here, we will be taking this. Now first we have to go for importing the data. So we have all these tables here. We also have to go for getting this called supplier master. And how will you get this supplier master? This will come from the sheet name called supplier master to this, right? So we can also go for here to say supplier master. So now if I run this program, I can see all this output which is coming. Now how to go for designing their relationship? Just to copy from the above. In this case, you will be going for dimension table 5, which will be connected to product master, where we have a primary key as supplier ID. You can see here, it is given as what? Supplier ID. So we can call this as supplier underscore ID. Underscore ID. Now, how to go for designing this relationship to get the output? Already we have done this here. Just to give you the background of this, how to do it. This is not going to be, we'll say data underscore 4. Now in data underscore 4, we are getting this output connected to this. Now we'll be calling this as final underscore output. So how to get this final output? Your data 4 will be connected to supplier master table. This is called supplier master, which we have created at the top. The supplier master table, the common field is going to be supplier ID. So ultimately, this final output which you have it, dot column dot values, it is going to give you, these are the list of variables which you have selected it here. Now keeping those variables, what you will do here, the supplier information like supplier name, location, contact, it has to be besides to the supplier ID only. That's what you can do it here. You can copy this location and this all details and paste it besides to the supplier ID. Now if you run this program, you get the complete output here, which is giving your product ID, product name, category, price, supplier ID, along with the supply details are coming. And how to print all the full. Do you remember, guys, what was that we retain? PD dot set underscore option. What was that? We're writing this, guys. Do you remember?
Sir.
At what syntax we write here?
Max column.
Display dot max rows.
So how do you write this? Display dot max underscore rows. Then we have to write what? None.
So display spelling. Again, DIS.
Yes. You will also write what? Display dot columns. So it is row or display dot row only. Let me run this query. Does it happen? It is happening. So now I can see supplier ID with supplier name is coming. So maybe I have written supplier twice. Just remove this here. Run the query again. I can see supplier ID with supplier name and full details are coming here. Does it make sense, guys? How to go for printing this output? Everyone?
Yes, sir.
Yes.
Right. So this is how we have completed the whole data model using Snowflakes now.